This video is part 1 for how to make a powerful subassembly from Autodesk Subassembly Composer. Let's start. First, open our Subassembly Composer from Autodesk. Our first step gives the name for this subassembly. I call it CAN's Engineering without space. Next, we'll insert parameters. For now, we'll insert parameters for the lane part and for the other input. Parameters will be inserted through our steps. Our default side is right, and we'll start by inserting at least the lane parameters. The first one, the thickness, pave 1t. This means pavement number 1 thickness. Then pave to t, the second pav, the third one, pave 3t, and the fourth, pave for t. These are all double. My default value for pavement number 1 is 0.05 meter. You can use any number for these default values. My default value for pavement number 2 is 0.2 meter. My default value for pavement number 3 is 0.2 to 5 meter. And my default value for pavement number 4 is 0.6 meter. Other parameters are pavement width and pavement slope. Pavement width is double, but the pavement slope is grade. Our pavement width is 3.5 meters and our pavement slope is 2.5%. This value is normal crown slope. And now we will insert our default name. These names are visible in Civil 3D. Therefore, you have to remember, but you can insert any name. Our first POV1 default name is AC thickness. Our second POV2 default name is base course thickness. Our third POV3 default name is subbase thickness. The fourth one is capping thickness. You can give any name and number as per your road condition, or the given typical section. You can change these numbers, not only here in Subassembly Composer but also in Civil 3D. They are changeable and visible in Civil 3D. Okay, our POV-W default name is lane width, and our POV-S default name is a lane slope. And now let's start our chart. First, insert the origin point. This one is point 1, and then we'll start making our lane. Our lane has 4 types of layers: asphalt, base course, subbase, and capping. But don't mess it up here and spoil the beauty of the chart. Let's insert a new chart. Here, open our new chart and insert a switch. And now we are going to draw our top link. By inserting the auxiliary point dot, this link will be our pavement number 1 top link first. This switches nothing but its side dot value. App 1 starts from point number 1 and it is slope delta x. Its slope is pavement slope. We have already inserted an input-output parameter which is minus pave-s. Leave the default value as it is and draw a link. Our first axillary link already drawn as you have seen it. Then next, insert the other similar auxiliary point and auxiliary link. It starts from point 1 again. It is slope delta x. Its slope is pavement slope pav s. For x value, leave the default value as it is. And finally draw a link. There is a problem here. Let's find it. Okay, here is our mistake. We have to give the initial point from point 1. Let us change the default. Namit is simple but case sensitive. Click on switch and again click on default, right capital R and IGHT, right? Come to the left, click on switch and again click on default. Right capital L and EFT left. Now give supervision for right side. It is right outside lane slope. And again give supervision for left side. It is left outside lane slope. After finishing this, inset a point. And delete this one for our chart beauty only and connect the above two auxiliary points to this point. The other important thing, we will change the name of app 2 and Alta 2 app 1 and Al1. The two links must be identical. And this point is slope delta x. It starts from point 1. Its slope is minus pav s. It is our pavement slope. And its delta x value is pav w, our pavement width. Our pavement width already inserted in input-output parameter before. Finally draw a link. Okay, we have drawn our top link for pavement number 1. Next we will draw all the links for our pavement layers. Let's start. Insert a point. All the points inserted here are delta x, delta y. It start from point 1. Its delta y value is negative pav 1t. Because it is pavement thickness for pavement 1. We already gave this name in input-output parameter, and please continue like this and as per the video. We already finished one side for our layers of a lane. And come here again and insert a point. You can use intersection point here, but since it is simple, please continue as before. It is also delta x delta y. It start from point 2, not from point 6. Its delta y value is negative pave 1 because it is. Pavement thickness for pavement 1. Please check the link has drawn and please continue like this. And as per the video. Now we have inserted all points for our lane. What is next? Draw a link between our points. It is simple, just insert a link. Our first link is between point 3 and point 7. It is the bottom link for pavement 1 and also the top link for pavement 2. Draw the next links. Now, as you have seen it, we have made all the links and insert all points for our lane layers. The remaining is shape. Insert our first shape and click here and again click a point inside. Our pavement 1 be the way we can give the code for our first shape here, but we will give all codes, 4 points, links, shapes, and daylights after finishing this powerful subassembly. But for the time being, if you want to know how the codes are inserting, it is simple. Just press Shift right double icon and pave 1 and finish it with double icon. Please draw the other 3 shapes as per the video. Let's continue our shoulder. Come to the previous chart and define the variables. The first variable is our top link, which is our pavement number 1 top link. The next variable is our variable slope for the shoulder. I will give the name for the first definition LS, which means lane slope height is double. Its default value is L1.slope. This slope is a variable slope for our lane, with different slope condition in super elevation case. The next variable is our variable slope for the shoulder. As we know, our shoulder slope varies depending on our lane's super elevation. Let's define it. I will give the name CALSHS. Means calculated shoulder slope height is double before giving the default value. Let's input our shoulder parameters. Its name is SHS. It is grade, not double. Its default value is negative for %. I will give this name shoulder slope. Now we will decide our shoulder top link. Its default value will be our new shoulder slope SHS. Insert a chart and open it. First we decide the condition. Please insert a decision. If our defined lane slope, which is LS, greater than or equal to 0, that means in higher case, what type of condition our shoulder will be. And again, we will insert a decision because we will have three cases. If our defined lane slope is greater than or equal to 0.07, that is 7%. Now we will set variables if our condition is true. Its name is calculated shoulder slope if open bracket LS is greater than or equal to 0.07, comma, negative 0.01, close the bracket. We will give 1% for drainage purpose. Again, insert a decision. If our lane slope is greater than SHS divided by 100, that is for %, define a variable. Its name is calculated shoulder slope and its value is LS minus 0.08. If is false, set variable value. If it is false, its name is calculated shoulder slope. Its value is SHS divided by 100. Let's go to the first decision if it is false set variable. Its name is calculated
ls,
shoulder slope
SHS
divided by 100. If open the bracket, ls is less than or equal to shs divided by 100, comma. Now we have finished all the cases. By the way, if you are good in if function, you can finish it in one decision. Then we can create our shoulder top link. Insert a point and connect all decisions to this point. This point start from 0.2 trillion is slope delta x. Now its slope is our new calculated shoulder slope CALSHS. Before giving a number for delta x, let's first give our shoulder width parameter on input-output. Parameter. It is SH width's double, its default value is 1.5, and its name is shoulder width. Now we can give our delta x, it is SHW. That is shoulder width, and draw a link. Here is a mistake, sorry for my default. It is not negative, it is simply CALSHS. Yes, it is corrected. Okay, let's check in super elevation case. Let's first check the higher case, change the super elevation to +9. It works. If I change it to the lower case, by changing to -9%, it works. You can check for others. I think it is enough for today. In next video we will see how to make different ditches in this one powerful subassembly. Different types of fill and cut daylights for different types of cut or fill material, and we will continue all the others. And also we will see all civil engineering softwares like EaglePoint, MS Project. In roads, in addition to Civil 3D Me YouTube channel is new, please Subscribe, like, and share. Thank you very much.